Assalamualaikum and hello. My name is Nazatul Farhana Binti Samudin and my supervisor is Dr. Khairunnisa. My FYP title is Fabrication of Arduino-based sensor for nitrogen dioxide concentration monitoring. This is my outline for this presentation. Nitrogen dioxide pollution. Nitrogen dioxide is a highly reactive gas that is commonly present in urban areas. This gas may affect humans' respiratory system, especially our lungs. It is also very harmful for vegetation. It will reduce the growth and the yield in agriculture. Other than that, nitrogen dioxide pollution is one of the contributors to acidic rain. The main outdoor source of nitrogen dioxide emission comes from vehicles exhaust and industrial. Urbanization and industrial background area are the most affected. As for indoor, increasing of NO2 concentration caused by the gas stove. Aware of this air quality issue, nitrogen dioxide pollution measuring instruments have been developed to monitor the nitrogen dioxide concentration since past centuries. The measuring instrument that mostly used was very big in size, which are non-portable and expensive. Apart from that, some of portable sensor gives error data measurement of NO2 concentration. For example, some studies showed that calculate NO2 sensor gives huge error of NO2 concentration. So with these limitations of nitrogen dioxide sensor or measuring instruments, the NO2 pollution monitoring in broader area is not feasible. Therefore, in this study, Arduino-based sensor was used because it is low cost. Gap of this study is to monitor nitrogen dioxide concentration using Arduino-based sensor in Malacca and College Siswajaya, Kuala Lumpur. Objectives of this research were to build a low-cost and portable Arduino-based with nitrogen dioxide sensor, to analyze nitrogen dioxide concentration at indoor and outdoor at Malacca using Arduino-based nitrogen dioxide sensor, and to analyze nitrogen dioxide concentration between urban and suburban area. Next, we go to methodology. Arduino-based of NO2 sensor was embedded with other components, which were nitrogen dioxide sensor, temperature and humidity sensor, and also LCD module. Arduino is a hardware of electronic base. The hardware is a microcontroller to connect, read, and write data taken received from the sensors. Before the device was assembled, the Arduino Uno was powered up by laptop to be programmed by using Arduino software, which is an integrated development environment or IDE. The source of code to program the Arduino was created and compiled using C and C++ programming language in the IDE. And then the coding was uploaded to the Arduino Uno. The Arduino will receive data from the sensors. Nitrogen dioxide sensor functions in detecting nitrogen dioxide gas concentration. And temperature and humidity sensor is to monitor the temperature and humidity of air surrounding. This is to ensure the performance of NO2 sensor. The raw data taken from the sensors was collected and been processing by the Arduino. And then it displayed directly to the LCD module that embedded to the Arduino. This Arduino also was linked with Blink application, which act as cloud storage to store the data taken. Blink application can be downloaded in a smartphone. The data taken also was showed directly in the Blink application for the real-time monitoring. The Arduino-based sensor was brought at study location at outdoor Kuala Lumpur. The experiment was conducted at College Siswajaya, Level 5 Block A. There were two sets of Arduino box that placed parallelly at the veranda as shown in the picture. The experiment was held for a week from Monday to Sunday for 3 sessions each day, which were at 8 a.m. to 9 a.m., 1 p.m. to 2 p.m., and 5 p.m. to 6 p.m. Study location at Kuala Lumpur is a busy city that compact with buildings at the surrounding. Next study location was at Malacca. The experiment conducted was at outdoor and indoor. Indoor was held inside a room that ventilated with fan. Meanwhile, outdoor was held at outside of the house, with height of 0.62 meter for both indoor and outdoor. The Arduino box was placed parallelly same as in Kuala Lumpur. The time and day also the same, which held for a week, and the time was at 8 a.m., 1 p.m., and 5 p.m. for a duration of 1 hour each session. The study location at Malacca is a residential area, which most resident is working people. The result from Arduino-based sensor was compared with Air Pollution Index Malaysia hourly table or APIMS. From the APIMS, the data taken was Batu Muda Kuala Lumpur to compare with study location at Kuala Lumpur, and Bandaraya Melaka to compare with study location at Malacca. Okay, so from this index value, from this index of APIMS value, the value was calculated using this formula to get a particular nitrogen dioxide concentration. So this APIMS value is the IP, index of the pollutant. So then calculated to get the concentration of the pollutant, which is CP. Result and discussion. This is the result for outdoor at Kuala Lumpur compared with APIMS data value. Okay, for both of Arduino sets, which were Arduino 1 and Arduino 2, there was a slightly different in data collected. However, when comparing with APIMS, data on Wednesday and Saturday have a significant difference. This may due to the rainy and windy day since the afternoon. Some studies have stated that weather factors such as windy and rainfall can result in lower NO2 concentration. The NO2 concentration was below the standard NO2 level that's set by Department of Environment, which is 148.9 ppb. Next study location was held at Malacca for outdoor and indoor. So this is the comparison of outdoor and indoor NO2 concentration. As can be seen in the graph, outdoor area has higher NO2 concentration with average increment of 13.34%. The outdoor was exposed to vehicular emission. So combustion of fossil fuels from car and vehicles produce NO2 pollution, thus contribute to the higher level of NO2 at outdoor. From the graph, at 8 a.m., often had a higher NO2 concentration compared to 1 p.m. and 5 p.m., especially on Monday and Tuesday, which were 63.23 ppb and 67.29 ppb respectively. This is because of people have morning rush at around 8 a.m. This is the comparison of outdoor at Kuala Lumpur, which is urban area, and Malacca, which is suburban area, and compared with APIMS data value. As can be seen in the graph, Malacca, which is the blue color, often had higher NO2 concentration than Kuala Lumpur during weekdays. This is because most of residents were out at peak hours, caused the increment of NO2 concentration. At Kuala Lumpur, it had higher NO2 concentration than Malacca during weekends. This may due to the people spend their weekends outside, and besides, there were no movement restriction implemented yet at Kuala Lumpur. Okay, in conclusion, Arduino based of a local sensor able to measure NO2 concentration at indoor and outdoor area. NO2 concentration at Malacca was 13.34%, higher than indoor area. NO2 concentration at suburban, which is Malacca, was higher than urban area, which is Kuala Lumpur, during weekdays. For future recommendations, fabrication of portable gas sensor using wireless platform such as Wi-Fi and Bluetooth. And next is comparison of Arduino-based sensor with NO2 analyzer that are available in lab or any conventional measuring instrument. This is the list of references. Okay, so that's all from me. Thank you.